All right, guys, welcome to lesson 12.2. We're going to learn some more identities today, known as the Pythagorean identities, and that will be it for that. We're not going to get to the factoring part till next time. I'll wait for that. So we're just going to talk about these Pythagorean identities. All right, so let's begin. So this should look kind of familiar to you guys. When you have the unit circle, the horizontal distance tells you the x value, and the vertical distance tells you your y value, and it's a right triangle, so we can apply Pythagorean's theorem to this. You guys remember Pythagorean's theorem? It says that if you take one leg and square it and add it to the other leg squared, it should equal the hypotenuse squared. Now, if you square 1, you just get 1. So we have that. Now, you guys may also recall that cosine of your angle gives you x, if that's my angle there, and sine of my angle gives me y. And so if I were to replace x with cosine and y with sine, I would get this expression here. And we have our first Pythagorean identity right there. Now, you could have the sine and the cosine switched. It doesn't matter because with addition and subtraction, with addition, the order doesn't matter. So both of those are equal to 1. So if you ever see in an expression that cosine squared plus sine squared is there, you can just replace that whole thing with 1 because that's what it equals. Okay. Now another thing that we can do is we can maybe get one of these things by itself. So maybe if I took the sine here and subtracted it on both sides, we would get this. Cosine squared is equal to 1 minus sine squared theta. Or maybe instead of subtracting the sine, we subtracted the cosine on both sides, in which case we would get sine squared is equal to 1 minus cosine squared theta. So all of these are Pythagorean identities, okay? And so we're going to have a summary of that on our next chart here, and here it is. So here's the basic one. And once again, it doesn't matter what order sine and cosine are in for this one because it's a plus. But you can also move things around so you get these other two expressions. Now for these ones, the order does matter because when you have subtraction, which one comes first matters. So you're not free to switch the 1 and the cosine around here. But you could switch these two around because there's a plus involved. Okay? All right. So those are what we call the Pythagorean identities, and we're going to learn how to use those to prove some other identities today. So let's go ahead and get started here. All right, so I don't see any Pythagorean identities here, so I'm just going to go ahead and start solving this the way that I normally would, which is by just changing everything to sine and cosine. So what would I change cotangent into? I would change that into cosine over sine. What would you change tangent into? Well, that would be sine over cosine. And on this side over here, we already have sine and cosine. Now don't worry, even though we don't have any Pythagorean identities yet, you'll see them in a minute. All right, so what we need to do is I want to combine these together. I want to get them to have a common denominator. So I'm going to multiply the top and the bottom here by cosine. And I'm going to multiply the top and the bottom of this other fraction by sine. And the end result will be cosine squared x over cosine x sine x plus sine squared x over cosine x sine x equals 1 over sine x cosine x. All right, now that I've got a common denominator, I can go ahead and combine my numerators together, can't I? So if I do that, I'm going to show my work up here. I would have cosine squared x plus sine squared x over cosine x sine x. And on the right side, we still have just this. Haven't done anything to the right side yet. All right. Well, here's my Pythagorean identity. You guys see that? Take a look at your chart. What is cosine squared x plus sine squared x equal to? It's equal to 1, and so we have this. And as you can see, these two sides are pretty much identical. We could actually just rewrite the bottom here because with multiplication, it's like addition. The order doesn't matter. So I'll just rewrite this other side. And therefore, as a result, we have those two expressions are equal. So what did we do in this problem here? Well, first two steps were just, stuff that we learned last time. Change everything to sine and cosine was first. And then since we had two fractions, we combined them into one by getting a common denominator. And after that, that's where the Pythagorean identity was. It was right there. And so the cosine squared x plus sine x squared became 1. All right? And so that's how you can use those. We're going to do a guided practice here. What you guys did, we're going to follow pretty much the same steps. So go ahead and do step 1 here. Step 1 is to change everything into sine or cosine. Pause the video here. When you unpause it, you'll see the answer to that first step. And there you go. Secant squared is 1 over cosine squared, and tangent squared is sine squared over cosine squared. Now, the next step is to get a common denominator here and combine these together. Now, guess what? They've already got a common denominator. So go ahead and put those together into one fraction, and we'll show you the next step. Pause the video here. When you unpause it, I'll have the answer. Okay, so now at this point in the game, we now have a Pythagorean identity. I want you guys to go ahead and look at your chart and see if you can identify it. Okay, so pause the video here, and when you unpause it, I will show you what I would do. All right, so now there's two ways you could go with this if you look at your chart. One thing you can do is you can replace this with something. So let's go look at our chart really quick, and I'll show you what I mean. You could replace 1 minus sine squared x with cosine squared x. I think that's the easier one to do. I'll show you the other option in just a minute. So I can replace this thing on top here with cosine squared x, which I'm going to write like this instead. As you guys know, that's how I prefer to write my trig functions, being squared. And at this point, we're kind of almost there, right? What's cosine x squared divided by cosine x squared? Well, they basically cancel each other out and leave 1, and the sides are equal, and we're good to go. Anytime you divide something by itself, you get 1, right? Now, that's not the only way we could have done that. Let's back it up a little bit. Another way you could have done this problem is instead of changing the top, you could have changed the bottom. So notice here I've got cosine of x squared. Well, if we just go back to our chart there really quick, you can find a cosine of x squared. It's right here. So you could replace that with this. So the other way that we could do this problem is as follows. Instead of replacing the top, what we can do is we can replace the bottom, and that would look like this. The top would stay the same in this case. And now the bottom would become this. But either way, you guys see it doesn't matter. They still are the same thing, and therefore you're left with 1 equals 1. So it doesn't really matter which one you choose to replace. Personally, I generally go in the direction of replacing the one that has 2 terms so that it becomes 1 term, like I did the first time around. So I would replace this one with a cosine x squared, because typically replacing 2 things with 1 makes things easier. Okay, but it's not the only way. When it comes to these proof problems, there's definitely always more than one way to do them. All right, so let's go ahead and have you guys do this one here on your own. So go ahead and pause the video and see if you guys can figure out the solution to this one here. All right, guys, so here's our answer to student practice 1. Now, something that I want you guys to start doing with these is I want you to start labeling your steps with what you did. So for the first step here, I just changed everything into sine and cosine, and the result of that would be this. So label that step, change everything to sine and cosine. Okay, next what did I do? I combined them together. I combined my two fractions together, so we'll call that that. Once again, write these steps down, because on your test and quiz, I am going to want you guys to write an explanation of what you did on each step, so I know what you did. Okay, the reason for that is because sometimes things get a little weird and ambiguous, and I don't really know what you're trying to do sometimes, so writing these steps out helps me see things clearly. All right, and how did I get from step 2 to step 3? Well, I did a Pythagorean identity. 1 minus cosine x squared is sine of x squared. And then from there, we can just simplify sine x squared over sine squared. That's just simplification. So there we go. Now, as far as the exact verbiage that I'm going to ask you guys to be using, I don't care necessarily, but you'll kind of see the common ways I word it. It should be kind of fairly obvious after we do a couple of examples how I want you guys to be explaining your steps. All right, so there's the answer to our student practice number 1. Let's go ahead and move along. Now, there are variations of the Pythagorean identity. As I've already told you, you could have it this way, or you could have it like this. Or you could have it like this. So those are two other variations, but there's even more variations than that. Let me show you what I mean. What we can do, instead of just having sine and cosine, we can actually change sine and cosine into other things. So let me give you an example. If I were to divide everything by sine squared x, I'm allowed to do that, because so long as you divide everything by sine squared x, the equation stays balanced. But I want you guys to see what happens as a result of that. Okay, now first of all, this is 1. Now what is cosine over sine? What is cosine over sine? Cosine over sine is actually cotangent, right? What is 1 over sine? That's cosecant. All right? You could do that over here with these ones, and you're just going to get different variations of this same thing. So if you divided everything here by sine of x, you're going to end up with 1 equals cosecant squared x minus cotangent squared x. And if you divided everything here by sine x, you're going to get cotangent squared x is equal to cosecant squared x minus 1. Now you don't have to write these down because they're all going to be on the next slide. But the point is that by dividing by sine squared x, I created 3 new types of Pythagorean identities. All right, let's do another one. How about instead of dividing by sine, I can also divide by cosine. But we're going to do cosine squared. What do you guys think that would be? Pause the video here and see if you guys could figure out what this would come out to be if we divided everything by cosine. If we divided everything by cosine, sine over cosine is tangent, and since it's being squared, it's tangent squared. This, anything divided by itself is 1, and this, 1 over cosine is secant, so 1 over cosine squared is secant squared. And so there's another type of Pythagorean identity that has tangent and secant in it now as well. So it turns out that as a result, we have a grand total of 9 different Pythagorean identities. Now these are pretty hard to remember. I actually don't remember them myself. All I do is I just know this one. That's the only one I really know, and I figure the rest out from there. So that's how I do it. Now, if you want to take the time to put all these on flashcards and try to memorize them, you can, but for me, that's a little bit too tedious. So this is the most important one to remember, because if you start here, you can create the rest of these. You can create these two just by moving things around. You could create this one by dividing everything by... Actually, let me back up. You can create this one by dividing everything by cosine. And you can create this one if you divide everything by sine. And then just by moving things around, you can create these other two. So if you want to take the time to memorize them, you can. But me personally, I just kind of start with this guy and figures everything out from there because that's too much memory for me to worry about. But there it is. So these are all different things that we can use to simplify expressions. So for instance, if you guys ever see a sine squared x plus cosine squared x, you could replace it. You could get rid of it and replace it with 1. Or if you see a secant squared x minus 1, you can get rid of it and replace it with tangent squared. Or if you guys see a cosecant squared x minus cotangent squared x, you can replace that with 1. So that's the idea, is that we have all these, we have 9 different Pythagorean identities, and we can replace them with a simpler expression. So like I said, I always replace the ones that have 2 terms. I replace those with its identity that has only 1 term. It usually makes things simpler that way, but you can go the opposite direction. I just don't prefer to go that way. All right, so let's go ahead and apply these. All right, so first of all, take a moment here and see if you guys can find the Pythagorean identity. Do you guys see it? It's right here. Now let's go see what that looks like by looking back on that last slide. 1 plus cotangent squared x, it's right there. What does that equal? I can replace it with cosecant squared. So that's the very first step we want to use there. We want to replace our Pythagorean expression, our expression there, with something simpler, which would be cosecant squared x. Now remember, I want us to start labeling our steps as we go. So what did I just do? Well, I just did a Pythagorean identity. So let's write that down. Pythagorean identity. That way I know you got from here to here by doing a Pythagorean identity. Okay? Now at this point, I don't see anything else I could do other than just go back to my regular process of changing everything into sine and cosine. So this guy's fine. It's already cosine, so I'm going to leave that one alone. This guy can be rewritten as 1 over sine x squared. And this guy here is going to be rewritten as the following. I can replace the cosecant on the top with 1 over sine. And I can replace the tangent on the bottom with sine over cosine. Okay, so what did I do there? I changed everything to sin and cos. Okay, so once again, make sure you're writing these verbal steps down because that's what I'm going to ask you guys to do on your quiz. Okay, so there's that. Now let's go ahead and start simplifying. All right, first of all here, if you guys think of this as cosine over 1, we multiply the top here and we multiply the bottom here, and as a result, we end up with cosine of x over sine x squared. Okay? So what did I do there? I just simplified. Maybe, but I would accept it also if you guys just put multiply, because that's what we did to simplify. We multiplied those two things together. All right, so let's continue. Now what do we do? Well, as you guys can see, we have a complex fraction there, right? And we've talked about how to simplify these. We want to get rid of these little denominators here. And the way that we get rid of those little denominators is by multiplying the top and the bottom by those denominators. So I'm going to multiply everything by sine x on the top and on the bottom. And let's see what that gives me as a result. The left side's going to stay the same. Now, if I multiply here, you end up with sine x over sine x, and they basically just end up leaving 1 on the top. And then for this guy in the bottom, I'm going to have sine x squared, because you have sine x times sine x, and then over cosine x. So what did I do there? I multiplied by sine. Now, maybe you just want to say simplify. I guess that's okay, but I'm just going to say I multiplied by sine. Now what do I do? So now I want to get rid of this little cosine here in the bottom. So now I'm going to multiply the top and the bottom of my big old fraction by cosine. Okay, so let's see where that gets me. And those cancel. Now I have this. And I've got those two sides the same now. And we're done. And I got to that final step by multiplying by cosine. So you could say simplifying the complex fraction, or you could just say literally what you did, multiply by cosine or multiply by sine. That's fine. But I do want you guys to give some kind of verbal explanation of how you got from one step to the other. Okay? So there it is. So we started off with the Pythagorean identity. So you're going to have at least that one thing to do in these problems. So let's go ahead and begin here. So start off here. Actually, I'm going to get you started on this one because there is a little bit of a strange step in this one that's not obvious. Notice how both of these are negative. Well, that almost matches this one, tangent squared x plus 1. The problem is that both the signs are opposite. So we have, instead of a positive tangent and a positive 1 being put together, they're both negative. So that's actually a little extra something there. We can fix that simply by dividing out a negative 1. So if I divide both of these by negative 1, they both become positive. Okay, so go ahead and do the Pythagorean identity first. So pause the video here and write a new expression by identifying the Pythagorean identity that is there. All right, guys, so there you go. So we can replace 1 plus tangent of x squared with secant of x squared. Okay? All right. So let's go ahead and move on to our next step. The next step is to change everything to sine and cosine. So go ahead and do that. Pause your video and see if you guys can get that. When you unpause it, you'll see the answer. All right, so there's a result. We can replace cosecant squared with 1 over sine squared. We can replace tangent squared with sine squared over cosine squared. And then we can replace this secant with 1 over cosine squared. Okay? All right. What do you guys think we would do next? See if you guys can kind of figure it out. Pause the video here, and when you unpause it, we'll see what you get. This last step here, I just put simplify and reduce. The sine squareds go away, and so you're left with negative 1 over cosine squared. And on this side, you have negative 1 over cosine squared. So they match, and we got there simply by reducing and simplifying. And so there you go. All right, so one more problem for the day. This is going to be a student practice. We'll let you guys go ahead and do it. Go ahead and pause the video here and give it a try, but remember, you want to start by looking for that Pythagorean identity, then change everything to sine and cosine, and then simplify from there. All right, so when you unpause it, you'll see the solution. All right, guys, so here we go. Step 1, this can be replaced with secant squared, and so that's a Pythagorean identity. Step 2, this can be replaced with sine squared over cosine squared, and this can be replaced with 1 over cosine squared. And that's changing everything to sine and cosine. Step 3, we can get this result by taking this expression over here and multiplying the top by cosine squared x and the bottom by cosine squared x. When you multiply the top, these cancel out, so you're just left with a sine on the top. And on the bottom now we have a sine and a cosine. Then finally, so that's multiplying by cosine squared. That's how I wrote my reason there. And then finally we can cross those off because they're the same on the top and bottom, and we end up with an identical expression, and we got there by reducing. And so that's how I would do it. Maybe that's not the only way to do it, But if you got there and you have good reasons justifying each step you have, then you're good to go. All right. So that'll do it for our lesson for today, and hopefully that was helpful. We'll practice this stuff in class. See you then.